Hello, and thank you all for joining us today for this educational Innovyze webinar. My name is Caitlin Nyan, and I'm part of the marketing team here at the Innovyze Portland office. In today's webinar, you'll learn how to better manage changing precipitation patterns. The new XPSWM and XPSTORM 2018 release provides the tools necessary to leverage Atlas 14 to improve stormwater and flood modeling. If that's why you're here, then you're in the right place. For those who may not be familiar with Innovyze, we have a long history of providing high-performing, innovative software solutions. Our intention is to make sure that in your work, you can design, model, review, and manage with confidence. This also means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in the industry. Innovyze offers a library of software programs for design, analysis, and management of water infrastructure, including powerful storm and flood modeling software like XPSWM and XPSTORM, which you will be seeing today. Now, on with our presentation. I'd like to introduce our presenters. Today's presenter are Anthony Couch and Matt Anderson, two of our product managers. Matt joined XP in December 2016 and comes with very valuable experience, especially for today's webinar, as he spent 6 years with Autodesk, most recently as a product manager. He spent over 16 years as a private engineering consultant. Over the past decade, he's been involved in improving the workflows and technologies that engineers use to study and design civil infrastructure and water resources. Anthony, or Tony, has been with XP Solutions for over 23 years. He's trained thousands of users, provided technical engineering support, and continues to drive the development of XPSWM and XPSTORM. Tony is our XPSWM guru, which means today that you are in very good hands. Thank you again for joining us today, and would you like to start our discussion, Tony or Matt?
Absolutely. So before we get too far into this, I want to ask a couple of questions just to gauge how familiar you are with NOAA Atlas 14. So Caitlin, can you launch that first poll question?
Yes, of course.
Cool. Thanks. So I just want to gauge how familiar are you? Do you utilize all the new depths in your modeling? Are you familiar but not yet required to use those depths? Or I'm aware of it, but I have to use other data in other data design requirements, or are you not familiar with Atlas 14 at all? Sharing our poll results. So we've got about 23% who are familiar, 22 and 21 using dated, 34% not familiar with NOAA Atlas 14 at all. Okay, thank you. All right, next poll question is, what is your stormwater modeling tool of choice? Kind of just trying to figure out where everyone is. We've got XPSWM, XPSTORM, Innovyze InfoWorks ICM on there, Innovyze InfoSwim, and then I've got a couple of the other EPA Swim or other competitive EPA Swim products, Heck HMS, or other proprietary tools. All right, that's good. 34% XPSWM, XPSTORM. Nice. Looks like 5% ICM and InfoSwim. About 30% using EPA Swim or other competitive products. And about 26% other proprietary tools. Cool. Today we want to kind of talk about two things. Leveraging NOAA Atlas 14 within XPSWM and XPSTORM. And we're also going to talk about XPSWM 2018.1 because I think they fit very well together. NOAA Atlas 14 is a set of updated rainfall depths for the continental US, but it also publishes some temporal distributions, and we'll go over what that is, as well as look at some suggested workflows within the 2018.1 release, okay? And then we'll cover some of the what's new in that release. And Tony and I will do this presentation and talk about these things. But let's kind of start with NOAA Atlas 14. Just what is it? What does it cover? And cover a little bit of why it's important. So NOAA is the National Oceanic, Atmospheric, and something or other agency. And they've published Atlas 14 for most of the continental United States. You can kind of see a couple of states up here in Oregon, in the Pacific Northwest there, Washington, Idaho, Montana, and Wyoming, not yet covered with Atlas 14. Texas is a big state there. It has some of Atlas 14 is published. Some of that should be coming out here in the next couple of months, according to what NOAA's been talking about. But Atlas 14 has been published. It's a precipitation frequency atlas. It has a website, and there's, give you a shortened URL there. If you go.innovise.com, Atlas 14, it'll redirect you to the web page, and you'll see this map of the continental United States. And if you click on your state of interest, you'll get into a nicer view that will allow you to pick where your project is. In this case, I grabbed a screenshot of Atlas 14, the point precipitation estimates here in Tennessee. And you get to select what data you want. In this case, for XPSWM, XPSTORM, you're looking at precipitation depth. And if we're going to use the temporals, which we'll show in a little bit, you want to look at the partial duration series. You'll go ahead and click your project location. The rainfall values that I have are actually Ohio, not Knoxville. But at the bottom of that page will be a big chart of the annual recurrence interval across the top, with the duration down the side. And if we look at that in a little bit more detail, we get, hey, there's a chart, and that chart helps us identify really that duration. What's that recurrence interval? Okay, by the duration. And we'll look at the 25-year, 24-hour storm, which in this case looks at the 5 1/4 inch rainfall. Okay, and that's our depth. That's what we're looking, and we're looking at that as a multiplier for these unit temporals, and that helps us begin that process. So, very high level. Most of the continental United States has Atlas 14 updated rainfall depths. Many of us are probably familiar with technical paper 40. That's an old chart-based version of that. It goes back a number of years. In the Midwest, there was Bolton 70, Bolton 71. So looked at and extended that rainfall. Well, Atlas 14 gathers a lot of that rainfall, past where TP40 was, and looks at certain elements. So one of the things that they did in doing that study on depths is they looked at the distribution of that rainfall over time. And in this case, Atlas 14 has published temporal distributions that begin to mimic actual rainfall events that they witnessed in that much longer history. Okay, and if you look at that 6-hour first quartile storm, you'll notice there are different cumulative probabilities from a 10 to a 90. So there's 9 cumulative probabilities for that 6-hour first quartile storm. Okay, well, they also published 4 sets of quartiles plus an average. I'm just going to look at the 4 quartiles, the 9 cumulative probabilities. But they also looked at different duration sets, which, holy cow, that's a lot of information. And what is this? Why do we want to do that? Well, it's not looking at the probability of one element. We're looking at testing each event. And why do we test each event? Well, we test each event because the hydraulics of our system, from large watershed studies to maybe individual developments, they all have unique characteristics. not only for runoff, but the hydraulics of the system. So we look at all of these events, test them all. In the end, look at the statistics of as how the system reacts. So, what difference does it make? Well, in this case, Tony will do a quick demo here in a little bit, looking at this project. In this case, I looked at the stage of the pond in that project. And in this case, this first quartile 24-hour storm, we have a whole bunch based on the first quartile and the percent occurrence. They all have different depths. Well, we look at stage 4, we can look at it and see, hey, the difference between quarter 1 and quarter 4, a lot of it has to do with when does the rain arrive, okay? And I want to contrast that primarily with the standard SCS type 2 rainfall, which is a peak flow. It's a nested intensity peak flow, that takes all of those intensities, puts all the high intensity ones in the middle, and kind of distributes those across there. And NOAA's kind of looked at issuing new distribution curves that mimic type 2. So type 2 is kind of going out the door. But as you can see, the contrast between a quarter 1 storm, quarter 4 storm, and the nested intensity. Remember, the quarter 1 and quarter 4 are the historic average, based on how they've looked at these things. So, rain doesn't always end up starting, Monday morning at noon, at midnight, and, by noon it's raining cats and dogs. So by looking at when rainfall arrives, we're going to get slightly different answers, and we've got to test all of those elements. So one of the things in one of our mid-year releases in 2017 was the introduction of this box and whisker plot. We have that ability to look at the statistics of the results and not just taking that nested intensity. So we can look at that 6-hour quartile durations there, 1 on the left, quartile 4, right before the middle, and in this case, you can kind of see that quartile 4 6-hour storm has the highest or the peak flow into this pond. So contrast that with the hydrographs that I showed earlier. The peak flow to the pond is a 4th quartile storm. The 24-hour duration, much lower values in there, but you can kind of see those. I don't want to call them true outliers, but peak flow is vastly different, okay, between the theoretical storms, which are 24 hours in duration, and that 6-hour peak flow. So we begin to look at, well, all of that information in that box and whisker plot. So how does Atlas 14 and local agencies come into play? And I think Minnesota, Wisconsin have done a really good job of providing that guidance. I think Iowa has some guidance in there as well. And it's a bit of a mixed bag across the U.S. There are people that still are allowed to use SCS, but Minnesota Department of Transportation kind of has indicated if you're going to use Atlas 14 rainfall and you're routing flow that have any considerable amount of storage, the type 2 or the MSE3 in Minnesota have a lot less impact to those. They view those SCS and those NRCS nested intensity curves much more as peak flow. They're good. They give really high peaks, very conservative, great for sizing stuff, the conveyance. But if you have flooding, they recommend using those NOAA temporal distributions. And in XPSWM and XPSTORM, we can actually build those events with global storms to help you find that critical duration. And in 2017.2 and now in 2018, the use ensemble statistics will help you find that critical duration. Now, we've gone ahead, and obviously Atlas 14's got a lot of temporals and things like that, but we're building templates and XPX files to help you along that way. Okay. Now, all of these files can be downloaded on a resource page. We'll give you the link on that later. But we have some of those. We've built some of those curves for you, kind of help you along the way. Now, sometimes, the Soil Conservation Service, or as they're now known as NRCS, they get into the Atlas 14 effort as well. And in this case, NRCS is replacing all of those type 1, 1A, type 2, and type 3 rainfalls and building in very specific curves for where you are. And I've zoomed in and provided a couple of maps. You can look at these maps and realize, holy cow, look at Colorado. You have different curves for where you are. And I'm pretty sure looking at some of those, just glancing at those, you can see that it might even depend on where you are in the county that, as to which curve, and they all have wonderful, unique, different names. Ohio, you're using NOAA, the type A region storm. In Colorado, Minnesota, you're using an MSE curve. So they all kind of depend on what they are. Well, NRCS has a bunch of those tables. We took all those tables. We've created XPX templates, so you can import all of those pretty easily. So if your regulations require maybe SCS, if you're using NOAA or the NOAA Atlas 14, I think you want to look at utilizing these different MSE or the different regions. Look at the website there for NRCS, find your region, find your map, find your curve that you need to use. So as I said, we're testing a whole bunch of storms. And you've got to find the critical duration. In this case, these are a couple of slides from Florida on projects. They talk about doing a critical duration analysis where they're looking at their precondition and their post-condition, identifying where the peak flows occur and how they change based on the numbered duration. Now, in this case, if you're using the NOAA temporals, you're going to have the 6, the 12, the 24, and the 96-hour storms. Florida has a different set of curves, but you're beginning to look at that. How does what you're proposing, if you're doing a project, how does that change the duration of the critical? How does it change the flow? How do you use that in XPSWM or XPSTORM? Well, at a minimum, you're probably looking at a 24 storm matrix. Look at those 90 and 10%, the extremes, if you will, of those NOAA temporals. So you've got 2 storms per quartile, per duration. That gives you really pretty much a 24 storm minimum, if you will, for each annual exceedance probability. So if you're looking at the 24 storms for the 25-year event, you'd have 24 storms at the 50 or the 100. Okay, that's at a minimum. I think what we'll show here in XPSWM and XPSTORM is we're running all 9 for one duration event. There's a lot of information there, but one of the things that Tony will talk about here in a second is utilizing this what's called the Solve Manager. Okay, and I'll talk to a lot of customers this year. We introduced the Solve Manager this time last year, talking about utilizing scenarios, utilizing global storms, and using the Solve Manager to solve all these concurrently. Okay, that helps us explore that what if. Okay, and if you look back, let me step back one here. There's your global storms. There's the first quartile 24 or 25-year, 10% 6-hour storm there at the top. Big long list of storms with an ensemble name to help us group and look at the statistics of those things in a bit. But running these things concurrently is a huge help, and we do that by pushing each simulation to a core on your machine. So my laptop's got 4 cores, 4 real cores, 4 virtual cores. It's an i7. I could run 4 simulations individually, all at once. So running all of these storms in a simple hydrology model, very quick. It sure beats. I think it's about 75 storms in this model. Sure beats them doing one at a time. So that's a bit of the what NOAA Atlas 14 is. Let's kind of take a look at that in a demo. So with that, Tony, I'm going to change presenters over to you. And let's see. All right. All you. There you go, Tony. I think you're on mute.
All right. Thanks, Matt. Hopefully everybody's seeing my screen. You'll let me know if that's not the case. I've started XPSWM 2018.1, get to this opening banner. And I've got teed up an example, Atlas 14 example prepared by Matt and myself. I'll just give you a little orientation to the model. It's basically just a representative one for us to teach you about the workflow and how all these components are working. So I have, in the runoff mode, I've got a residential node with catchment data. And in the hydraulics, I am simulating this, some dual drainage down this street and pipe combination down to a pond, and then ultimately it goes to an outlet here in this stream area. The rainfall data in XPSWM and XPSTORM, I'll just say XP from now on, is basically stored in what we call the global database. In our global database, we can have a set of storms, and you can see the list here. As Matt had mentioned, you know, our example has Atlas 14 rainfall, first quartile, and the 10P, 20P, 30P. These are the various temporal patterns, the shapes, if you will. They're all for the 6-hour. We are able in the software to create a kind of a specialized scenario where we're only altering the rain, and we call that feature the global storms. It's accessible from the job control here in runoff mode, global storms, and directly from this toolbar here. This section is the global storm analyzer. So I'll edit this and show you here that we've got a set of storms that are all active. In fact, we have several quartiles as our ensemble group, all with the same depth, because this depth is the Atlas 14 depth for 6 hours and the location of the simulation. If I go a little further, you'll see I've got now some 24 hours. So I did 6-hour set, both first, second, third, and fourth quartile. And similarly did the same for 24 hours, different depths. But you'll notice again that these are all grouped in these ensembles. This this set of information, you know, you can directly type in here, you can copy and paste, and you can import from XPX files. So it's not like a big task to populate this at all. You know, that's quite fast. This button here, ARR Storm Generator, this is a tool specialized for Australia, where it basically takes you to the equivalent Australian site to Atlas 14, where you interact with a map, and essentially you can create all these storms automated. You know, perhaps there will be an opportunity for us to do the same for Atlas 14, but you know, right now there would be a lot of exceptions, like you'd click on the map in Washington, for example, state, and you'd find no information, right? So perhaps when it's more complete, we can maybe get some more automation for you. The ability to solve the model with a Solve Manager is accessed from Analyze menu. In fact, it's Shift F5 keyboard equivalent. The Solve Manager then, as Matt had mentioned, is going to start solving these storms 4 at a time. That's really going to be helpful in the sense that, you know, you could say with a 4-core computer and 4 at a time, it's, you know, 1/4 of the time. After the simulation is done, I've done that. It doesn't take very long. I think it's about 1 or 2 minutes to do all of these storms, but we could go to the review results. I've selected this residential node. I'll go to review results. And of course, right now it's going to just look like a lot of information, like maybe too much to manage, right? But I'm looking at the flows for all of those simulations at once. You could change to look at different information, but you know, for now I'll stick with the flows for all of those storms. Now you could look at a particular storm, and you could look at perhaps different ensembles, like the quartile 2 ensemble set. Right now we're talking about the group of 9, the 10 through 90%. And one thing that you can actually gather from this, although it's maybe a little bit of a manual process, is that you will see that there might be some trends or may not be some trends on, is it the 10, the 20%, etc., that actually generates the peak flow. In this case, it's the 10, but it's possible that I could grab a different quartile and we could find that the peak perhaps now in this case is the 90. So we're talking about a certain return period, a specific duration, and a different pattern that still fits the general statistics, right, for the depth and that return period. Now just the shape of the storm is getting us a different peak flow. Now in this case, just notice it's like double. So the shape of the storm is actually something that's significant. Of course, this is exaggerated or mitigated based on the hydraulics of your system, the size of the catchment, its percent impervious, how much storage there is there limited conveyance, etc. The ability to create the ensemble statistics is accessed here from the results menu. Ensemble statistics, Shift F10 is the keyboard equivalent. In fact, there's also an icon here on the toolbar to get there as well. I'll just get it from the menu though. And this ensemble statistics then is presenting us with all of my ensembles, you know, its description and what's its mean, what's the maximum and minimums for the parameter here that I've selected from the combo box for the specific object called residential. It's here that we can generate the box and whisker plot. The box and whisker plot by default will hide outliers, but you could show the outliers, and in some of them you can see there are a few outliers that show up as points. This can be interrogated just by hovering the mouse, and you could learn a little bit more. For example, I can extract exactly the mean, right? 25.4228, but I can see that perhaps it's about 25 just from the scale of the graph. You can also create an output file from this. It creates an output file that you could look at in an editor, and you can just see that here. So it's the same information more or less, right? But a little bit more detail perhaps for each specific storm. It's the details for that. And we could also export this data, creating a CSV file for use in perhaps another statistics package, or perhaps to Excel, etc., or some sort of report. So it's just easily managed as a CSV file rather than a formatted text file. As Matt had mentioned, perhaps I will quickly just show you this. I think we have the time. If I go to the Resource Center, let's type in XPSWM Resource Center. Wrong login. Let's try here. And I go to download resources. Here you can see, for example, in the model templates, this is where you could go and extract these XPX files, these CSV files, etc. that we have for, oh, we've started, we have some of them here for you. And of course, it doesn't exclude you from doing your own, but we've sort of started this process. So with that, I'm going to switch over now to the PowerPoint presentation I've got kind of queued up and talk about what's new in XPSWM 2018.1. The first is a new tool where you can take a catchment, perhaps it's like a 40% impervious catchment, and you can now split it between its pervious and impervious surfaces. One of the motivations for that is that there are some hydrologic methods like SCS, Lawrenson, used primarily in Australia, for example, that treat the catchment as an aggregate, not as separate surfaces where the percent impervious is considered directly connected impervious surfaces. So take a small lot where there's a lawn and a driveway and a roof. If the roof surface goes down a downspout and is directed to the driveway, it's kind of like directly connected impervious area. It goes to the inlet without being subject to infiltration. So it's important to be able to have the early flows of the hydrograph, the rising limb of the hydrograph correct, the low intensity rain give a good response, and so it's useful to have impervious and pervious surfaces separated. Well, this has been a bit of a manual process, but what we do now is we actually allow you to right click on the catchment polygon and access the split, or go to the Tools menu to calculate node and split, and it brings up a dialog where you can choose which ones you would want to split, and split, for example, catchment 1 to its pervious and impervious 2 and 3. Even do things like set new infiltration records or copy them from the existing catchment, and including rerouting surfaces like taking the impervious and putting it on the pervious. That would be a choice in the route to catchment option. So here, for example, is the result of having split a 53% catchment number 1 into its number 2 and 3, its pervious and impervious catchments. In XPTABLES, we created a few new features where you can gather the statistics information on a group of data, a column, or perhaps a partial column of information. So you would go into XPTABLES, you'd highlight the information. For example, I've highlighted max water depth column. You click on the field statistics icon, and it generates this information, the minimum, max, etc. These typical values, which, by the way, they're editable. So if you wanted to grab this maximum, you could right-click on it, copy it, paste it somewhere else in the table, in another program, etc. Similarly, we created a new way for you to speedily make edits in XPTABLES. You would grab, again, a set of data or partial column, and then click on the block editing tool. This block editing then brings up feature that allows you to do the following operations. You could replace, right, set equal to, including a text string. You could add, subtract, multiply, and divide. So if, for example, you wanted to add 1.5 feet of elevation to all of these nodes, like in the picture, then you would choose the add 1.5, click OK, and then these elevations are all going to be increased 1.5 feet. In the review results, we've created a new, basically, object group called Inlet Capacity. IC is the icon to press on the toolbar. What it does is if you have a node in hydraulics that has inlet capacity, previously there was a kind of involved workaround in order to see that hydrograph. A user could have, for example, made a fictitious link and labeled it in a special way such that it was the node name with a $R for rating, like the rating curve of the inlet capacity, and you would be able to get this graph. But you know, that's not really user-friendly or intuitive at all. So what we've done now, if you choose review results and you're in the hydraulics and you've grabbed some nodes and they are inlet nodes, you can just quickly choose the IC button and it will display the inlet capacity for the various nodes. For example, in this picture, I've got 2 inlet capacity nodes being shown with their upstream and downstream water surface elevations. Of course, that's like the surface, subsurface, and then their flows. The velocities are suppressed since they're not calculated. Notice that these have maximums of 0.05, which was in fact the maximum capacity on the rating curve that I generated for them. So at most they were grabbing, well, this was a metric model, 50 liters per second. In the dynamic long section, we did basically some modification of the way that multiple conduits were presented. So in the 2018.1 version, we actually allow both labels and, say, results to be shown and not overlapping. It's down here where I'm drawing your attention to. Previously, they wrote on top of each other and you only saw the one model result. You didn't see both sets of results. And what we've done is we basically separate with a slash the various pieces of information. So pipe A, street A, these are the flows for the pipe and the street. Again, that 50 liters per second because of that inlet capacity maximum that was on there. So this isn't just limited to 2, there's up to 7 conduits in a multi-link, so you could have basically 7 of these things being shown. So you'll see them all at the same time. To the left here, if you're not familiar, this is a way to toggle, make visible any of the multiple conduits in a multi-link. So I guess an older workaround might have been that you just show one or the other so you can read the values and they don't overlap. Also in the dynamic long section, we did a little bit more work. Here's an example where, you know, perhaps you've noticed that you can track the X, Y of your cursor, but this is now possible to be toggled on or off. And the Solve Manager, perhaps I might even get a chance to demo it today, but in the Solve Manager, it now defaults to starting minimized. Previously, you would start the Solve Manager and all of the engine windows would appear on your screen, perhaps like on a 4-core computer, 4 of them, and they would have the focus, and then it would make it a little bit more difficult or would be interruptive for you as you're doing other work. Let's say you're starting the process to solve 70 plus storms and the windows keep popping up while you're trying to work on Excel and it grabs the focus. So they start minimized and essentially you can see them down in your toolbar of programs that are running and they're not interruptive anymore. There's also some guidance with the Solve Manager. In fact, we have decided that a threshold of 50 is perhaps appropriate. And so if you attempt to solve a model with more than 50 storms or 50 scenarios, or the combination of those, then we're going to prompt you with this message and I guess suggest to you to use the Solve Manager. So if you click yes at this point, then it will switch to using the Solve Manager. If you choose no, then it will be a consecutive solving, one after the other, and the total duration of the simulation is going to be the sum of each individual, rather than getting the opportunity to run them in parallel. All right, let's just quickly demo some of these things. And let me switch over to the software. I can use the same model, I believe, with you. So the catchment splitting, for example, this node, I'll just show you, it has one catchment of 44 acres, 25% impervious. So I could access it from Tools, Calculate Node, Split Catchment to Pervious Impervious. And if I do that, then brings up this dialog. I can choose to split this catchment, perhaps to number 2 and number 3. And I could use the following infiltration records, or I could copy them from the existing split catchment. I click the OK button, and if I go back to the node, you can see that it's turned off number 1, and it's done 25% of this for the 11 for the impervious catchment, and for the pervious it's duplicated the other values. And if we go in here to the node, we can see also, for example, that it's duplicated the rain record, and it's duplicated or placed the appropriate infiltration record into each of these subcatchments. Let's go to show you what happened in the XPTABLES for the field statistics. Perhaps I'll just choose one storm, and I'll pick maybe something that's got data rather than results. The yellow highlighting, by the way, means it's selected in the plan view. So my widths are 900 and 500. I could just select these, and I could do the field statistics, and I can see the minimum, the maximum, the sum total, and the mean or average of those, and standard deviation. As I mentioned, this text is something that you can copy and paste. Now the block edit, for example, for these block edits, perhaps I would want to, I'm calibrating a model, width is a classic calibration parameter. Maybe I can multiply these by 1.2 to make them 20% more. I can click the OK button, and now I have 1.2. And then I could, rerun the model basically and see that kind of a response. Maybe I could make a scenario, and so I could do that in a comparison. The Solve Manager prompt, if I go to Solve now and solve this, because I have a lot of storms, here's that message that I had mentioned where it says there's a large number of simulations, it can lead to long run times. Do I want to use the Solve Manager? If I say yes, of course, it proceeds that way. And if I say no, it does the old simulation of one after the other. So anyway, I'll just start that process. Oh, I'm not sure what I've done to the model here. Well, anyway, you saw the message. That's what I wanted to show you anyway. All right, so let's get back. Just a couple of expectations that you may have for the new version. First of all, when you install it, it's got changed branding to Innovize from XP Solutions, so it's going to be located by default in a different folder than the past. So you'll find this now in Program Files x86 Innovize rather than XP Solutions folder. The resource downloads, which I took you to, those are useful for not just Atlas 14, but other rainfall distributions and other templates, which can help speed up the creation of models. XPSWM 2018.1 is going to be available at no charge for people with existing InfoCare. So if you're up to date on your maintenance contracts with us, then there's no problem for you to be able to get this. The download is going to be available mid-February. That's our anticipation. We're in the testing phases now. And it's available from the support portal. But both current and expired license holders are going to be notified by email about the license, about the upgrade with the license file that would be required for the installation in the cases of people with current InfoCare. So this new XCF file is required. We consider 2018.1 a major upgrade to 2017.1, and hence a new license file is required to allow it to happen. I did want to remind you kind of where. So, if you go to the support portal for XPSWM and XPSTORM, if you're registered there, if not, you could register there. But there's a download section, and when you click on downloads, you'll be able to have a link to download it, the installer, but also in that email you'll get that. And in the software itself, when you start in the opening banner, there's the ability to check for updates. So let's say we're talking about mid-February. If you have this activated, then if the update's available, you'll get a message right below here that will say that the update's available. All right, poll question, and I'll turn my time off as well and let Matt and Caitlin deal with this.
Thanks, Tony. Yeah, so the one question for you is pick one of the items that you learned today that kind of excites you the most. Obviously, we covered the temporals initially. We've got the ability to query our ensemble statistics. We've got the box and Whisker plot. Maybe it's to save a review, keep you from having to do the $R for inlets. Is it the solve manager functionality, the block edit functionality? Yep. All right, yeah. Interest on the Atlas 14, ensemble statistics, solve manager. Good. Noticed a couple of questions. One of them was about the Atlas 14 temporals. Can you scale the 6-hour distribution down to, say, a 3 or a 1? According to NOAA, no. Because of how they did their statistics, the 6-hour storm is the only duration that is available. So one suggestion, Circular 173, it was written out of this Illinois State Water Survey. That's the source of the Huff distributions. Those are time scalable, but they are obviously slightly different. There's a difference between how Bolton 70 and Circular 173 were developed in looking at what a first quartile storm. First quartile storm is a time duration, where the Atlas 14 is a distribution duration. So that's a slight difference there. Are there plans to build these into InfoSwim? That's a good question. We probably can definitely look at that. As we are one company, that's something that we can, the interoperability between our products is something that we're looking at, actively looking at, trying to figure out what the best way, to do those things. We do have certain tools that, for example, in Australia, that are beginning to share that kind of information. So as we go forward, any suggestions, as product managers, we're always happy to talk to you about, what your desires are. Thank you for joining us today, and I hope you enjoyed the presentation. We'll go ahead and leave this up here for a second. That's our email addresses. and our general phone number. So we'll go ahead and thank you for joining today's webinar.